Yeah, so my name is Karl Kreder. I'm the CEO of GridPlus. GridPlus makes a hardware wallet called the Lattice One. We also make these cool things called safecards, which are effectively like a pin-protected seed phrase. So just out of curiosity, like, who has crypto in this room? How many people have a hardware wallet in this room? Okay, so maybe 20% of people that have crypto have a hardware wallet. So it tells me that the other 80% of you have like less than a few $1,000s in crypto, or you're just being massively irresponsible. So does everyone know what a hardware wallet does? Shaking your head in the orange hat, what does it do?
A hardware wallet just stores your keys such that they can't be exposed to like the internet. It's much safer. A hardware wallet, you don't have to worry about like getting hacked and like your just a file being like copied.
Right.
And, your keys just being rubbed.
Right. Yeah. So fundamentally, like, right, the keys that we talk about when you have your crypto assets, that mnemonic phrase. Everyone knows what a mnemonic phrase is. Yeah. Like that is how you derive all of your public-private key pairs. So that fundamentally like is the password to your crypto that is stored on the blockchain, right? If anyone ever gets that password, they're gonna have your crypto, right? So if it's not your keys, it's not your crypto. So what's your name in the orange hat?
Max.
Max. So like as Max was saying, what a hardware wallet does is it creates a secure environment to store and use those keys that has much better security than your computers do, right? So like in the crypto space, especially like in the NFT space, everyone will always be trying to like compromise your computer, get you to download like a doc with like a macro enabled or an Excel sheet with a macro enabled. There's like a million extensions that you can potentially get where someone can effectively like root your computer. It's a lot easier on a Windows platform, and it's quite a bit harder on a Mac or a Linux platform. However, none of the platforms are perfectly secure, and nobody can like argue that they'll ever have like perfect OPSEC like on their machine, right? So if somebody sends you an email, like we get phished all the time. And it'll be like very keyed up phishing too. So, our like accountant got an email the other day that was from an address that looked like one of our employees. And it's like, oh, can you please check, that my payroll went through, and like they knew the day that we'd get paid on because like, we use JustWorks. So like everything about it like made sense, but like it wasn't from an actual email. It was a spoofed email address and like it had an attachment. So like he was getting phished, and if he had gotten phished, and that was able to, elevate sort of remote permissions on his computer, and he had his keys on his computer, his funds would instantaneously be gone, right? So it's basically impossible in the crypto space to like depend upon your computer if you have a high-profile Twitter account, if you're in Discords, if you're trading NFTs, like you will eventually get your computer owned, like 100%. So if you have more money than you're willing to walk around with in your pocket, and it will make you sad if you lose that money, like you should not have it on your computer, right? And so like that threshold is different from everybody, but like that should be the metric of like, should you need a hardware wallet or not? So what the hardware wallet does, as Max was saying, is it's really two things. One, it keeps your keys off your computer in a secure environment, and two, it allows you to confirm what you're signing prior to signing it, right? And both of those things are just as important as the other, right? So one of the issues that you have with like hardware wallets, like probably most people here have ledgers. Probably like 5 Lattice users in the room. Trezor. You got a Trezor, right? Well, one of the issues though, when you interact with a smart contract, do you ever notice that they potentially present a large blob of hex, or they show you just a hex string that represents what you're signing, right? So if you go to Uniswap and it says sign this transaction, it just shows you like 32 bytes. And you're like, click, sign. Right? But you don't know what the hell you just signed. You just like signed a hash that could have been 3 kilobytes in data. So what's been happening in the last 6 to 9 months is that hackers are getting more sophisticated, and what they can do is if they own your front end, even if you have a wallet, if you can't check what you're signing on that wallet, they can still steal your funds. So like Badger DAO in December had $150 million stolen using Ledger. So they're using MetaMask and Ledger. Somebody owned their computer, changed what that payload looked like. Ledger has that small, shitty little screen that you can't really check or decode, and they got $150 million stolen. So they were like technically using best practices in that they were keeping their keys off the machine, but it's the second thing as well, which is verifying what you sign. So when you look at Lattice One, what we're trying to do, and what we've done, is basically like made a Web3 type wallet. So we have a 5-inch touchscreen, and we have some cool features like human readable. Everyone can see that. Super sweet. 5-inch touchscreen, and this interfaces with popular wallets. So you can use this with like MetaMask, you can use this with MyCrypto, you can use this with anything. And I'll just leave it at that. But if you go to our website, you can like learn more about the cool features that we have in terms of ABIs, like what chains we support. This is actually like a really, really cool feature because like seed phrases, for everybody that has a hardware wallet, and for everyone that has a seed phrase, how many of you keep it in your sock drawer? Right?
Yeah.
Like you back up your crypto, but like fundamentally you're just like keeping it somewhere in your house, which like is taking that thing and it's like turning it back into something that's like very stealable like cash. The cool part about these cards is they're pin protected. So like if I put this in your sock drawer and somebody steals it, they don't have your pin, like they're not getting your money. So we actually have like a security challenge where we sell these cards with 10 ETH on them, and we've been doing that for a year, and no one's ever gotten the 10 ETH, right? So like, this card, has quite a bit of ETH on it, and I, am fine carrying it around, throwing it on the floor, like losing it, like I have backups. If you find it, you're not gonna know the pin. So, it's a much better sort of security topology than a seed phrase. So the question though becomes is, why am I working on that project? Does anybody understand why I would put time into making a hardware wallet for people? Go for it.
Make adoption easier.
Right, make adoption easier, but to what end?
They can transfer money between each other, like
Yeah,
peer-to-peer?
yeah. So self-custodian and peer-to-peer payments only happen if you're not using a custodian, right? So like, if we all keep using Coinbase and Gemini and everything, what they're gonna eventually do is they're gonna create secondary back ends, and they're gonna say, oh, well, I'm gonna allow you to send money to like someone on Kraken or someone on Gemini or someone in Coinbase, and I'm just gonna like, charge you 1%, and that's great and all. So they're gonna build these second layer systems, and we're gonna reintroduce custodianship, we're gonna reintroduce censorship, into this system, which we originally built to be censorship resistant and decentralized. So like, when people talk about decentralization, a lot of times they talk about how many Bitcoin nodes are being run, or how distributed is the mining power. But the thing that they rarely consider is how many people are actually custodying their funds and using their funds for practical commerce. And so the concept here is we want to lower the barrier to entry of self-custodianship enough that everybody custodians their own funds. Even, like your mother, who's, 70 or 65, depending on how old you are. Your parents are probably younger. But like, this is something that like everybody can understand, right? It's just a pin protected card that has money on it. So like, it looks like a debit card. In many ways, it acts like a debit card. So like, that topology makes it much easier and sort of eliminates that UX barrier to entry in self-custodianship in crypto. So like, that's why we work on the Lattice One. Now, the main topic of my talk though isn't the Lattice One, it's actually another protocol called Phonon. And everything that I do in the crypto space is always working towards the concept of decentralization and how we sort of realize the unfettered vision of like fair money, like in crypto. So like, if people are like wondering why blockchain is Texas blockchain is like so revolutionary, it's because we're disrupting money. Like that's 100% what we're doing here. There's like secondary applications of, supply chain stuff and tracking and, sort of, time stamping and verification. Like there's other use cases, but like the big thing that is happening here is we are creating an extra national global form of free and fair money. Like full stop. Like that's what crypto is, right? And we can like create these other applications like DeFi, and we can create this stuff like NFTs, but like the main thing that we're doing is we're reinventing the entire monetary system. So to do that, we have to like understand these sort of pain points that we create when we re-centralize that monetary system back to people like Coinbase, and Kraken. So we have to design systems that will allow this to scale to a global monetary size. And so what do you guys think is the requirement for transactions per second if we are to replace money using blockchains? Anybody know? We talked about this, so like you don't get to answer. Go ahead.
Isn't it like up to like 65 or 100,000 transactions per second?
Okay, that's a very good number. What would that get you? So if you had that many, how many transactions would a person get to do in a day?
I don't know, maybe I do like 10 max on a day.
One. So if you can do 100,000 and change, everyone in the globe would get one transaction a day, right? So that's 7.9 billion people doing one transaction a day, right? So like, clearly that probably doesn't quite get us to where we need to go, right? Maybe it's on the order of like 300 or 400 or 500,000 transactions per second, right? What currently can Ethereum do? 10, good number. What can Solana, not so decentralized, do? Like 2,000, right? So how do we go from 10 in a properly decentralized system, 2,000 in basically like a private, authority-based system, to get to 400,000 in a decentralized way? How do we do that? And that's fundamentally the question that we have to ask. And that's fundamentally the question we have to answer, because if we can't answer that question, we're going to end up having to fall back onto centralized systems again, like Coinbase and Kraken. So two projects that I work on, one, a lot of these guys here are involved in, is called Quai, and that's building a scalable, sort of multi-threaded proof of work blockchain. So that, gets us a long ways, but is going to top out, say, at like 20,000 transactions per second. So it's still not going to get us to the hundreds of thousands that we need to replace money. So Phonon is an additional project that I'm working on, and I'll intro to that. And this is, one of the cool properties here is it's infinitely scalable. So like every blockchain fundamentally has this problem of if you have a node and if you have a ledger, how do I get transactions through the internet into a consistent set of transactions which can be worked on by miners to cause a modification of the state of a ledger, right? You're fundamentally always going to be limited by the bandwidth of the internet and the ability of those peers in that set to come to consensus. And the more peers you have in that set and the more transactions that you push through the network, the harder it is to get to a consistent set, and the harder it is to get to consensus. So like, what happens to Bitcoin if you throw 100 transactions per second at it? Anyone know?
All of them get dropped.
They either get dropped or Bitcoin forks. Now, well, so fair. So Bitcoin has a block limit size. So if we opened up the block limit size and we let the miners mine in as many transactions as they wanted to, you would start forking the blockchain, because you'd be trying to commit so much data to so many nodes at the same time that they would never be able to come to agreement on what the state of the chain is, right? And that's a fundamental limitations of all blockchains that have any sort of centralized ledger and nodes processing transactions. So what Quai does is it basically creates shards of that, and it uses proof of work to help create objective state transitions across shards. But fundamentally, every one of those shards is still limited by this concept of you can only get so much network throughput in a shard, but we've created more shards. So you can do that to some degree, but if we take that to an infinite scope and we say, okay, let's have 100 shards, let's have 1,000,000 shards. How useful is 1,000,000 shards? Right? Because at any given time, how many people are in the 1,000,000 shards that you're going to be able to transact with? So if I can only transact with 50,000 people in a shard, and every other transaction that I have to publish has to go cross-shard, I'm going to have to wait a long time for that transaction to propagate and settle. So as you create more shards, you get more siloing. As you get more siloing, the utility of the network goes down, because the time to settlement, the number of the people you can directly interact with, the time to settlement goes up, and the number of people you can directly interact with goes down. So there is like a fundamental limit, no matter what construction you make, to having a ledger-based system and scaling. Any questions on that?
Yeah, you just had the transactions get dropped on Bitcoin. If too many are pushed at once. What do you mean by dropped?
Well, so technically it doesn't get dropped. They get queued into a mempool, and they like wait. If the block limit was raised such that the miners could mine in as many transactions as were being published, you would end up getting forks. So because it takes time to propagate the data set after the block is mined, and people are missing data in that data set, as more transactions go through, they end up missing more data when the block is mined. So then it takes longer for them to collect the data to be able to validate the block and then be able to continue mining. So as that happens, you're more and more likely to get two miners on separate heads. So you'll have two blocks, right? So it's a blockchain. Then all of a sudden, because like we're trying to push so much through it, you know, one miner goes over here, one miner goes over here. So now we have two heads, so we split the network. So some miners are gonna go here, some miners are gonna go here, and we don't really know which is gonna be the winner yet. So then the next block that's found, if it is found fast enough, that or you know, significantly earlier than this next block is found, then the chain falls back and reorgs to this head. But the more you push through, the more often that forking is gonna happen, and the longer those forks are gonna take, and eventually you're gonna get forking of forks. So if I keep pushing through, put through the network, this fork could have another fork. So now I could have 3 heads, and then I could have like 6 heads, and then this was never gonna come back together. So you're gonna effectively blow up the entire network. Do you get that?
Yeah.
Cool. So let's dive into Phonon. We kind of understand the problem, right? And I would argue that Phonon is a key sort of solution to it. So what is Phonon? Phonon is the world's first SIM-enabled scalable layer 0. So who knows what a SIM is? Show of hands. Everybody knows what a SIM is? What's a SIM?
I have a question.
Go for it.
So, like, you said they're being, like, viewed and, like, they're waiting in the loophole.
Yeah.
Could that not be addressed by just adding more miners to the network? Or
No, the problem is everyone ends up like running at different sets. So there's like a couple properties that like happen with databases, and these properties get strained in a distributed database. So if we only are thinking about it as a database, the property that gets strained is consistency, right? So consistency is you have a data set, I have a data set, and those data sets are consistent, right? So like, you know, if Owen or Max like sends some Bitcoin, right, to me, and that's in the ledger, right? If we're pushing too much data through the network, you may see that transaction, and I may not yet see that transaction. So our sets are now inconsistent, right? And then we have the second step of consensus. So consensus is the process of mining. Right now, in Bitcoin, those two things happen simultaneously, and that when we mine or hit consensus, we've technically established what we think is the consistent current data set for the network, right? But what that means is like you mine that block, I'm now going to have to catch up. So I'm going to now have to ask all my peers, hey, what transactions just happened? Because I only have 800 of 1,000 that just went in that block. So I need to go fetch these 200 transactions. And that takes time. And then once I gather them all, I need to put them into the Merkle tree and I need to validate. That takes more time. And then I finally get to the point where I'm like, okay, you got a valid block, I'm gonna start mining again, right? And as we, you know, in a given Bitcoin block, maybe that takes, I don't know, 20 seconds normally, right? But as that 20 seconds keeps getting longer and getting closer to 10 minutes, it's basically a linear percentage of blocks will be forked. So if I have like a minute delay to do verification, 10% of all blocks produced will get forked. Now, as that keeps increasing though, that's like a super linear property. So at 10%, it's not really gonna be 10%, it might be 20%, right? And when I get to 30%, I might already be at the point that the network's just, it's blown up and it can't come back together. Right, so like we only have so much sort of margin that is sort of allowed for forking before the network just goes into shambles and can't be recombined. Does that kind of answer the question?
Yeah, that makes sense. Thanks.
So the really cool part, okay, so SIMs. Everyone know what a SIM is? Thing you put in your phone, right? So it's basically identical to the chip that's on this smart card. So like your smart card, your chip cards in your wallet, your SIMs on your phone, those are effectively secure enclaves, and those are secure enclaves that are using Java Card OS. And we can depend on that security and leverage that to do really cool things. So in this particular case, we have Phonon, which is leveraging SIMs to create an infinitely scalable layer 0. So what is Phonon? Phonon is a highly scalable, privacy-preserving protocol for exchanging any digital assets using smartphones, SIM cards, smart cards, or eSIMs. And the property of it is as close to being called physical cash or digital cash as anything that has ever tried to use that term. So if we talk about Bitcoin, Bitcoin is not digital cash, right? When I want to do a transaction, right, I pull with cash. I still carry it just in case. I know it's like a relic. But, right, I can come here and I can give Kunal $50. The cool part about doing that is that was like a private transaction. If I didn't tell you that I just gave Kunal $50, none of you would know about it. But more importantly, I don't need to put that on the internet and broadcast it to the world, right? It's just a peer-to-peer transaction. Bitcoin isn't digital cash because every time that you make a transaction, even though it's been labeled that, I have to sign the transaction, even though I'm doing it with a pseudo-anonymous set of keys, fine. I have to broadcast that to everybody on the internet. I have to pay miners to mine that into nodes, and then that transaction gets put into a ledger that's recorded in perpetuity. So how is Bitcoin digital cash? Like, it isn't digital cash. It's just a fun marketing label, but it doesn't actually describe the properties of physical cash because it can't be transacted as an actual peer-to-peer identity. Does everyone get that? Yeah? So when I say Phonon is like physical cash, we have literally figured out how to take any blockchain asset and effectively mint it into a digital thing on one of these smart cards that makes it, from a property standpoint, identical to that. So that is what Phonon is. The mint is like who gets to make these bills, right? With the Phonon card, anybody can effectively make a bill and they can back it with any asset from any blockchain, L1, L2, whatever they want. Okay? So how are we actually doing this? Sorry, why are we doing this first? Two reasons why we're doing this. Blockchains haven't yet gotten scalability and they haven't actually gotten like perfect forward privacy. But with Phonon, we can do both of those things. So how does that work? We've talked about blockchains, we've talked about ledgers. So this is sort of the normal sort of topology, right? You have nodes, the nodes are mining potentially, they're processing transactions, and then they're committing transactions to the ledger, which is updating the state of the system. What Phonon does is it uses these secure enclaves, which can be interfaced with any one of those blockchains. So that could be Bitcoin, that could be Ethereum, that could be Solana, that could be Monero, it doesn't matter. But it interfaces with those blockchains, and once you get something into the Phonon system, it can transit this Phonon system in a strictly peer-to-peer way. So anybody that has a Phonon card can transact with anybody else that has a Phonon card. And remember, this could be a smart card, this could be a SIM card, or this could be an eSIM. Do people know what eSIMs are? Kunal, tell us what an eSIM is.
No electronic SIM.
Embedded SIM. That's what it stands for. So in your phone, if you have a modern phone, there's actually one of these chips effectively soldered into your phone. So I could use this phone without a SIM card if I leverage the eSIM. Now, in the world of Phonon, we can actually deploy and provision a Phonon applet directly onto a phone without having to deploy hardware. And there's around 2 billion of these phones already in existence. So the cool part is when we're talking about this system, you're thinking, oh man, you gotta have a card that I gotta like do something with. Once we get those provisioned to phones, from a user's perspective, to get on and use the Phonon network, it'll simply be downloading an app. and we'll be leveraging the hardware that already exists. So what's kind of the way that you make a phonon, and then how do you use a phonon? So any one of these interfaces could be like your interface to the phonon world. Now, every one of these has to have one of these secure enclaves somewhere. Your phone has one, right, as an eSIM. Your Lattice One hardware wallet, you can plug a phonon card into. You could also have a laptop that has, a smart card reader, or you can connect a smart card reader, or you could even use it at like a point of sale terminal. So those are all possible interfaces that you could use with Phonon. So how do you actually create a phonon? What you do is you create a key pair on one of these cards, and the guarantee that these cards make is that that key pair will only ever exist in exactly one place. That is like what Phonon is. I can create a key pair, and I can guarantee it only ever exists in one place. Yes? So like that's what the cards are going to guarantee you. The other thing that they're going to do for you is they're going to allow you to securely swap that phonon with any other card in the network. So if I want to make a phonon, I can make like a 1 ETH phonon by creating a new key pair, exporting that public key, sending money to that key pair, and then loading the metadata onto the card. I now have a 1 ETH phonon. I could then exchange that 1 ETH phonon with anybody else in the network, and then they could optionally exchange that an infinite number of times in the network. And at some point, if somebody wants to take it out of the Phonon network, all they have to do is destroy the phonon by exporting the private key. And then the private key is then usable back in its original context of an L1 or an L2. Do you get that? You're squinting. Ask your question. Don't be shy.
I was just like reading the text stuff. I didn't really have a question. I already kind of know a little bit about Phonon to begin with, but I didn't have a question.
Okay, my text is too small. Cool. So one of the cool properties of this, though, is that Phonon doesn't depend on any blockchain protocol. So has anyone heard of Layer 0, like the project? Anyone? Couple people? One guy? Does anyone actually know what it means to be like a layer in a tech stack? So like, what is the difference between like an L1 and an L2? Who can like define that for me? Why is something called an L2 versus an L1?
Isn't an L1 where like the transactions actually settle, and then like the L2 are usually just to help kind of make the throughput or allow more transactions to go?
That's what they do. That's absolutely correct. But why is it called L2? Why do we call it a 2 versus a 1?
So it's just built on top of it, like the layers, like in order.
You're close. Did you have something else?
That was kind of what I was gonna say. Are L2s technically off-chain?
It's okay. So we'll expand upon. It's built on top of, right? So the 2 is dependent on the 1, but the 1 has really no idea about the 2, right? So like when we talk about tech stacks, it is what do I have to put down first before I go to the next layer? So what piece of technology has dependency on what piece of technology determines where it is in the technology stack. So if I were to build a cross-chain interoperability system using smart contracts so that I could bridge things, what would that be?
Layer 0.
Be an L2. Because each of the smart contracts depends on the protocol that it's interfacing with, right? So I can't build a bridge without knowing something about both protocols to which I'm bridging. So the bridge is then dependent on the protocol, so inherently it has to be farther up in the stack than down. The cool part about Phonon is Phonon doesn't actually even know what a blockchain is. This card doesn't know what a blockchain is. It doesn't have a node. I can't sync anything. I can't hold a ledger on here. So what are we doing? We're trading key pairs. So all Phonon understands is key pairs, right? I don't know if I'm in Bitcoin land. I don't know if I'm in Ethereum land. I don't know how to make a Bitcoin transaction. I don't know how to make an Ethereum transaction. All Phonon knows how to do is trade key pairs securely. So what does that make Phonon?
Layer 0s.
It's a layer 0, exactly. So the cool part about that, though, is we actually only need to support 3 signing curves to be able to do this for basically every asset in existence. there's a K curve, an R curve, and an Edwards curve. And if we support those 3 signing curves on this card, we support every asset that currently exists in the blockchain world. So there's a lot of cool things that you can do about that. Go for it.
What's a signing curve?
Sorry?
What's a signing curve?
Open to the room. Who knows what a signing curve is?
That's just a curve you use to like generate your key pair.
So it's a different field in EC. So all of this is ECC, right? Elliptic curve cryptography, which is a form of, asymmetric cryptography, and it's basically used by like all blockchains. So when we talk about like K versus R versus Edwards, we're just talking about the mathematical equation of the elliptic curve, which we're using for signing. And some of them like have mild differences or benefits over others. And we can get into those, but functionally for blockchains, they all kind of do the same thing. It's just those like mild benefits have caused a few blockchains to use different signing curves. So one of the ways that we can ensure, right, the original guarantee that I set a phone on is what? Come on, guys, interact. It's unique. The key pair only exists in one spot. So how are we actually accomplishing that? One of the key pieces to this is something called a physically unclonable function. So does anyone know what a physically unclonable function is?
It's where you use the process variations and stuff in silicon to generate a key pair.
Exactly. So if I had to kind of put it in layman's terms, it would be like an electronic snowflake. So like when you make a chip, there's always going to be variations in sort of every transistor or gate that you put together, right? And what you can do is you can purposely create a set of gates that is like a race condition. And the process variation will then determine how that race condition will end up getting satisfied once the chip is made, but you can't predict it, right? So what that does is it creates a physical piece of entropy which we cannot actually replicate. And that is a physically unclonable function. So this card has a physically unclonable function, and if I use it properly, that means that you can never copy this card. Like you can never copy the key pairs that are held on this card. There's like no way to do it. Now, that's different than like memory, like NAND or something, right? Because if I have NAND, I can decap a chip, I can go to like an electron microscope, and I can see the state of the memory, and I can find the key, right? But with a physically unclonable function, if you decap that chip, you're going to alter the outcome state of the puff, right? And you can't read what it's going to produce in its state unless it's happening through the OS, right? So you can create a system that very reliably has a unique piece of physical entropy that can't be copied. So that's one of the key parts of how we can guarantee that a key pair will only exist in one spot. So this is the technical part. So this is actually how we're doing it. And this is about 7 steps, and I'll go through it. Feel free to interrupt me if you have a question. So what ends up happening is if you want to create a phonon, Alice deposits an asset into a public address on her card. So she's created a fresh phonon. It's uninitialized because it doesn't have an asset. She exports the public key, she sends an asset to it, and she loads metadata, right? And that metadata will say that she has, say, a 1 ETH phonon. That's part 2. So then let's say Alice and Bob want to trade a phonon. So they're going to have their cards effectively establish a secure channel between the cards. So this is Diffie-Hellman key exchange. We use a certificate and a challenge response process to verify authenticity of the counterparty, right? Because like I can't just have any old card interacting with me because it's not going to necessarily guarantee that it's making sure that key pairs only exist in exactly one spot. It's not a genuine phonon card. So that process of creating the secure channel and doing the challenge response allows both Alice and Bob to know that they're both using phonon cards. And then what Alice can do is she can propose a phonon to Bob and say, hey, Bob, I have this phonon. It has this public key, and I'm going to tell you that's worth 1 ETH. Now, what Bob is going to do is he could take Alice's word on that, and say, hey, Bob, I have this phonon. It has this public key, and I'm going to tell you that's worth 1 ETH. Now, what Bob is going to do is he could take Alice's word on that, and say, hey, Bob, I have this phonon. It has this public key, and I'm going to tell you that's worth 1 ETH. Now, what Bob is going to do is he could take Alice's word on that, But there's no guarantee that what Alice is giving Bob is actually 1 ETH. But what he can do is he can go onto the Ethereum blockchain or Infura or query an RPC endpoint, and he can find out that that public key pair has 1 ETH encumbered to it. He can then say, great, Alice, I agree with you that that's 1 Ethereum. Let's do this transaction. So then Alice's card basically encrypts that packet, and that is actually the process of sending. It's not actually transiting the wire and getting to Bob's card, it's the process of encryption. Because once it's encrypted to Bob's channel key, Alice deletes it, and she no longer can do anything with that encrypted packet because she doesn't have the decryption key. She just made an encrypted packet. So it's now a blob to Alice, it's a blob to anyone else that's looking. The only person that has the decryption key is Bob's card, and at either a synchronous or at some point in the future, Bob can read that encrypted packet into his card, decrypt it, and load that Phonon. And then whenever Bob wants to, oh, that's the next step. I keep going one ahead. And then whenever Bob wants to, he can either then do secondary transactions in the network, and he can do that at effectively a transaction every 2 seconds. So if there's, say, 8 billion Phonon cards in the world, we could do 4 billion transactions per second, which is well over our 400,000 that we may need. And yeah, there you go. So questions about Phonon?
So like the current value of Phonon, like you can like buy it on a crypto exchange and stuff like that.
So there's a Phonon DAO token. So fundamentally, like Phonon is, like as projects go, it is most akin to like a blockchain. But so it needs sort of like a foundation and a mechanism of governance. However, Phonon like fundamentally isn't a blockchain, right? Because we don't record any of this stuff anywhere. But it still needs sort of that governance profile on it.
So for 2 users to transact a Phonon, do they have to be, both of their SIM cards have to be connected to the internet at the same time, right?
Well, so it is interactive, which is, I think, your main point.
Yeah.
But you don't have to use the internet. You can use any topology you want. So, like, if we did it on our phones, we could actually swap, Bluetooth pairing keys at the same time, and we could just go over Bluetooth. You could do it on a LAN. You could do it on whatever. So, like, a lot of times you'll use the internet, but you can use any process that gets communication between the cards. It is interactive, though. Yep.
How does this work just with the phone, like you were saying, if you don't have the card with the puff?
So the phone has the embedded SIM in it, and the embedded SIMs also have puffs. So we can provision the embedded SIMs remotely. So like most phones now that you guys would buy have an embedded SIM in them. So for you, it would just look like downloading an app.
So if Phonon's infinitely scalable, why are you building a layer 1 conjunction with it? Or is it a secondary project?
Okay, so I'll open that up. What's the deficit of Phonon, guys? What's the biggest? There's a couple problems with this, right? What problems can you see with Phonon?
It doesn't keep a ledger, or it doesn't have memory.
Expand upon that.
Well, like,
I don't like ledgers. Like, why do we fundamentally need a ledger?
well, I missed half of the presentation because I was eating pizza. But my understanding was
Can't blame
that Phonon keeps a little bit of data in each node, which is the key pair as well as the metadata,
Yeah,
and nothing else.
that's right. But like, why is it not good to not have a ledger?
It's harder to do more complex things, like a lot of DeFi apps would be like kind of impossible without smart contract capability.
Yes, so there's limitations of what you can do, because like we're not offering to do smart contracts, we're only offering to move key pairs associated with assets. Now you could make cool implications of that for smart contracts, right? Because like you can effectively make smart contracts that have weird off-chain state transitions. So let's say you have NFTs and you made a Phonon NFT, you can now trade that NFT and you wouldn't have to pay the creator fee and you wouldn't have to pay the OpenSea exchange fee. I'm not gonna say if that's good or bad, I'm just saying there's interesting things you can do by moving key pairs off chain. But I'll put it out there unless somebody has another idea of a big deficit here.
I was wondering, back to the graph that you showed, the number of transactions that you make per second relies on the number of puffs.
Yeah.
Phonon puffs. So, does it basically rely on everybody obtaining a puff for it to support that many transactions?
No, it's just every pair in the network can do a half a TPS. That's it. So when I do a transaction with you, my card is talking to your card and no one else. So every 2 cards we add, we can add another half TPS.
Wait, so are you losing that decentralization? The transaction's not going to be like the network?
No, nothing's going anywhere. It's just my card, your card, that's it. There's no broadcasting, there's no recognition.
Yeah.
We're just trading keys off chain in a secure way.
It uses the internet, right?
It doesn't have to use the internet. You just have to have any communication channel open. It can use the internet, but it doesn't have to.
Is it because it's physically stuck in one place?
Haha! Yes. So remember how I said it's physical cash. So if I go ahead and I burn this bill or I burn this card, the net result's the same. I don't have my shit anymore, do I? Right? So that's fundamentally a problem with Phonon. So when I said Phonon is digital cash, in every respect, it looks like digital cash. So the same sort of problems that you have with cash, you'll also have with Phonon. Now, does that not make it useful? No, it's useful for a certain set of things, right? It's useful for a lot of things. Everything that's on your desk right now, that Chick-fil-A, this water, those headphones, you buy them in Phonon in 20 years. You're not gonna buy them on an L1 because the L1 is potentially too expensive. Right? It provides you an anonymous, free, scalable layer to interact with any blockchain. But if you lose it, you lose it, and there's no way to back it up. Right? That's one deficit. What's another deficit?
Wouldn't you would still be limited, create the Phonon, you have to do a transaction on the chain that you want to transact on to do the initial deposit, right? So that would still be a limitation.
That's also a deficit. Yeah, but you can use that asset that you create an infinite number of times in the network. So there's kind of this minting fee, but that minting fee can hypothetically be amortized over 1,000 transactions. So it can become very low. But then you have to create a new model, kind of like Coinstar in some ways, where somebody is a minter, a collector, and potentially a redistributor. Right? So if I have low value Phonon, instead of going back to my L1, the fundamental limitation here isn't Phonon, it's the L1, right? And it's economically unfeasible or very expensive to redeem a $1 Phonon. I'll have a change maker, and that change maker will look like Coinstar, and I'll take all my $1 Phonons, I'll collect them up, I'll find $100, I'll give it to my Token Star, Phonon Star service, and they'll give me $85 back, or $90 back. I'll have one $90 Phonon that I can bring back to the blockchain. And then they'll have those 100 Phonons, and then when somebody's oh, I need a $1 Phonon, but I don't want to spend all that minting money because it's not economically tenable to do so, they're just going to give them a $100 Phonon, and they'll get 100 ones, right? So you can have a change-making service just like we have cash and coin currently. The other issue, though, is cash and coin. So does everyone get that these are UTXOs?
A bunch of folks may not know what a UTXO is.
So a UTXO in Bitcoin land stands for unspent transaction output. But in the Bitcoin context, when you use a UTXO, you have to use the whole UTXO. If you're in Ethereum and an account-based model, I can have one Ethereum in account, I can take 0.1 Ethereum out. In the Bitcoin model, I have a bunch of UTXOs in my wallet, which I don't see. It just says your net balance is $37.3, right? And I may have a 10 BTC in there, I may have a 5 BTC in there, I may have a 0.16248 BTC in there. And then when I go to spend, my wallet will ideally in some smart way determine how I should aggregate and use the UTXOs in my wallet to like compose a transaction. So when I create a phonon here, and I create like a 1/8 phonon, when I trade that, I can only trade it in its entirety. You say, well, that's a problem. Kind of. Right now, if you look at US dollars, how many denominations do we have? We have a penny, we have a nickel, we have a dime, we have a quarter. I'm not going to count the 50-cent piece, those don't exist. We have a 1, we have a 5, we have a 10, we have a 20, a 50, and a 100. That's 11, right? So if you have 11 different sized phonons, you can have a system that's like fundamentally identical to cache. And we've somehow figured out how to get precision in what is a physical UTXO system using cache for the last however many hundreds of years. We can do the same thing in a digital context, especially because one of these cards presently can hold 200 phonons. In like 6 months, that'll go up to like 1,000. So when you have cash and coin on you, you probably only are having 40 items at most, right? So if we can cover 200 or 1,000, we can obviously get precision in any use case we need.
How many phonons can a eSIM hold?
Well, yeah, so this one can hold about 200. Well, oh yeah, so the eSIMs are very similar to this. So you would expect similar numbers, 200 to 1,000. Yeah.
Are you actually storing the key on the eSIM, or are you using the PUF to encrypt the key?
Yeah, so the PUF encrypts like everything, right? So
it doesn't actually have storage.
It does.
It does.
It does. Right, because every new phonon you create, you have to create a new key pair.
Yeah, my question is if that.
The PUF is
It's stored.
encrypting all the data
Yeah,
that's being
it's
stored.
Then like on chip on the microchip.
Yeah, so the actual keys are in NAND, right? But to read the key, you have to have the PUF. So it's using the PUF as like a root that makes sure that all data that's there is secure.
So like each phonon is a private and public key, and like there's 200 different sets of keys on there. Like
Yeah, you can make up to 200 per card. Yeah.
Okay, and then like basically you're just sending the key pair to the private key to the person you're exchanging with.
Yep.
And that's how okay.
Yep. And you can also do swaps that way too. So like if you have Bitcoin, I have Ethereum, and we have willing counterparties, we can set up a system where we do a swap. And like that swap can like be using a little smart contracting. We can have like an optimistic fallback system, and we can guarantee completion of a swap. So that's how you get interoperability amongst assets, is because these can hold any asset. If I want to move across blockchains, I just find somebody that's willing to do a swap. And then we can exchange any asset for any other asset just using Phonon.
Referencing your analogies like nickel, dime, penny, and
Yep.
whatnot, so if you have, so the user of the card, they can assign the amount that goes to each phonon. that
Yep.
they have?
Yep.
And then what's that process like?
So, I mean, we try to abstract it like as much as we can, because we don't really need you to look at your UTXOs, just like you don't look at your UTXOs in a Bitcoin wallet. But like, if you want to, you can. But most of that can be abstracted away by just wallets and good decisions. So,
We've got another session with Pinex, so I just wanted to give you a heads up. Probably have like one question left, and then might have to end it after that. But yeah.
Okay. I just have one like comment.
Yeah.
I just want to like blow your minds if you weren't like already blown away with Phonon. So I'll do this in like a minute. So the other thing that we can do is so everything I've told you right now is what we call a backed phonon. But what we can also do is we can actually mine on these cards. So we can find something that's mathematically unique, just like we do with mining for Bitcoin, by looking for a nonce to end up creating a hash that, say, has a lot of leading zeros, right? The cool part about that, though, is I can guarantee the uniqueness of the existence of that nonce and then provably exchange it without having to like have verification in a ledger-based system. So I can effectively tokenize mining shares on the cards, and those are what we call native phonons. So native phonons are atomically verifiable in the network, and they never have any existence on a blockchain whatsoever. So the really cool part for you guys to noodle on is what we've actually done with Phonon is we've recreated blockchain, except it doesn't have blocks, it doesn't have a chain, it doesn't have a ledger, it doesn't have nodes, and it's not even dependent on the internet.